In this video, I wanted to look at cleaning up some of the other areas on these parts and using the projection pocketing operation and the curve machining operation. So I'm still with the simulation open here. We have a couple different areas of the model or of these parts that are flat, but they have some texture to them now because we used the ball end tool to machine those flat areas. And also we have some inside edges that aren't very sharp, both here around the base of these truncated cones up here, and then around the base of these walls here. The round tool will leave a radius in those locations, and if I go back to the program, you can see that our actual objects have have nice sharp edges in those areas. Here you can actually see that with this object that I don't have any walls drawn, and I'll talk about that a little bit when we get to looking at that object. First thing I'd like to look at is the projection pocketing. And so if I wanted to, I don't have a curve here now, so I'm going to go ahead. If I wanted to clean up this top surface, this bottom flat surface here, and this flat surface here, what I can do is, there's a couple things I could do. First, I'm going to get a curve for this object here, and so with my part regions layer as my active layer, I'm going to just select that surface and do a dupe border. So that will give me my region for my projection pocketing there. This is going to be a little bit harder, a little more challenging to define, but in this part what I want to get is just the flat area that's within these lines. So what I would do, I don't have that curve set yet, so I would grab those regions and actually do a project to C-plane, and I'm going to ask me if I want to delete input. I'm going to say no, and so that will project those lines down to 0. I will do also a project to C-plane with my outside border for that part. And now if I zoom selected, if I go ahead and select all of those objects, I'm going to toggle over to top view, and if I do a curve boolean, I can click the inside region to keep, and that's going to trace the boundary of that layer, and if I hit enter, it's going to give me a continuous closed curve that outlines my flat area here. And in this case, my curve is down at 0, but once again, that doesn't matter. All that this is setting is a window of where I'm cutting in my stock or on these individual part geometries. So with that, I'm going to hold Shift and click the other areas that I want to do my projection pocketing. And I'll go up to Machining Operations, 3-axis, and Projection Pocketing here. And so there's my regions. I want to go, and in this case, I'm going to use a smaller tool. I'm going to use our 1/4 inch tool for foam, and I'm going to use a flat cutter because these are flat surfaces. This will be my 3rd tool, so I want to come down and change the tool number. So I'll change my tool number to 3, save edits to tool, click OK, OK. My tool number updates. Our clearance plane should be the same. The feeds and speeds will be the same. I'll just click load from tool. Under cut parameters, so this is similar to a pocketing pass, a 2-axis pocketing pass, but also similar to the 3-axis parallel finishing. So this we're applying to flat surfaces, so we should be able to use a pretty big step over and still get a nice clean result. If these surfaces were sloped slightly, I may opt to do a smaller step over in effort to try to reduce some of the machining effects. But for this case, I think we can get away with a 50% step over of the tool diameter. So we're using a 1/4 inch tool. That will be a 0.125 step over. Again, if we were doing a slope surface, we may want to make that much smaller. Once again, we have these other tabs up here, but we don't really need to worry about adjusting anything under those tabs. So I'm just going to click Generate, and what we should see, I'm going to toggle our toolpaths on again, is within that region that we've given it, it's made a pocketing pass, so it's an offset pattern of that region, and we have our step over, our toolpath stepping in at our step over distance to clean up those flat areas. And now if we go back up to our simulation and simulate to end, we should see that we get a nice flat finish and also cleanup on the inside of some of those edges. We also get some cleanup there too as well. So if we toggle back to the previous pass where we left off, I'll zoom in on this part because I think it's the most obvious, and I'll hide our toolpath visibility, but we can see a pretty dramatic improvement on the bottom surface of that part after we've added the projection pocketing. So I'm going to move back out to the program. The projection pocketing will it does stay within this curve. It doesn't go beyond it. So it may leave slight edges for us to clean up. You may choose to just leave it and clean it up by hand afterwards. One tool that can be pretty useful, one operation that can be useful to clean up those edges a little further will be the curve machining operation. And so I want to look at that next, and I'm going to apply that to, so I'm going to grab my base curve region for each of these parts. I'm going to go up to machining operations, 3-axis, and sorry, I said curve machining. We're actually going to do the pencil tracing operation here. So if we look at the pencil tracing, what it's going to give us are our different part regions. For the tool, I'm going to continue to use our 1/2 or 1/4 inch flat down cutter here. Feeds and speeds, again, there's I'll just click load from tool, but the settings will be the same. Our clearance plane is the same, and so under the cut parameters for this, we have some options to sort of clean up these areas with multiple passes, but generally that's not needed. Under advanced parameters, there are some other options to control some of the settings, but this will illustrate sort of what's happening. So what the pencil tracing is doing is it's going around and looking for bottom edges. It's analyzing this geometry for those lower edges that need to be cleaned up, and it's going to go through and add a toolpath to clean those up automatically. So you may want to adjust some of these parameters based on your geometry, but usually just the default settings will give you a pretty good result. So we haven't really changed much. All we did was select our tool, and that's pretty much all we need to do, and then we can click generate. And we should see a toolpath generate to clean up those inside edges in each of these different areas. Let's see, we did get an error here. Let's try to resolve what's creating that. So one thing that I'll typically do if I get an error like this, I'll try to isolate my curve region. So I'm gonna just remove all my regions, and I'll just set I'm going to set one region at a time, and now I'll try to generate just this one object. I'm thinking more than likely, so if we turn our toolpath visibility on, you can see that we got a nice cleanup of that inside edge here with the pencil tracing. I'm guessing what caused that error is that this object here doesn't really have any of those inside edges. But just to be safe, I'm going to select my pencil tracing, do a Control-C, Control-V, and for the next one I'm going to try these other two regions and omit this region. So we'll generate the tracing for those two areas. And you can see that we get tool paths to go in and clean up those inside edges. And before I simulate that, you can see, so this pencil tracing is an algorithm that's analyzing this geometry that we're giving it, the geometry within the regions that we've selected. And it's looking for flat inside corners. And so one way that it can be problematic is it can sort of add toolpaths where we don't necessarily want them, and so we may need to look at other ways of cleaning up edges if the pencil tracing is giving us either curves that are not necessary, that may make the process take much longer, or maybe curves that will affect the surface finish, and we can't really omit them because of the way that the algorithm is generating the tool paths. But let's look, I'll go up and we'll try to simulate this again to the end. And once this is done, what we can do is toggle back and forth and see the difference after even our projection pocketing is finished, to see how much that pencil tracing is cleaning up. So let's see if we can notice any difference. So that was after our pocketing, and if we look at the pencil tracing, it didn't necessarily clean up any more of that edge. But if we zoom over to this object, you can see that actually the pencil tracing is going a little bit farther on the edges, so it's going a bit beyond where the projection pocketing left off. But all in all, it's not doing too much. But if we go up to this object, the cones, you can see that the pencil tracing has cleaned up quite a bit of what used to be there. So there was a really strong radius, and the pencil tracing removed a lot of that. There is still a little recess here, And how we would have to address that is actually we would want to go to a smaller ball and tool to correct, to get closer into this bottom corner. But we're always going to be left with something there that we'll either need to live with or go in and clean up by hand after we've removed our parts. So if you used a 1/4 inch tool, you would reduce how much of this sort of stepped bottom edge you'd have. And if you wanted to go down as low as an 1/8 inch tool, you could do that as well to get better definition in those areas. But that's more or less how you can use the projection pocketing and the pencil tracing to clean up some of those inside edge areas or flat or light sloped areas in your parts. I'm going to stop there with this video, and in the next video we'll look at some of the other ways of finishing cutting out these parts. Thanks.